find the general solution of the given system. So here is the system in terms of vector x prime. First, you need to find a minus lambda I. Okay, so what is a? Let's call this matrix A and then subtract it with lambda I. That gives you this matrix. Okay, then find its determinant. You are going to do this chunks and then set it equal to 0. So for lambda, you will get lambda equal to -2 plus minus 3i. Okay, let's take a look at the first case when lambda equals to, plug it into here, you will get this matrix augmented with 0. Okay, from the first equation I have k3 equals -5k2. Okay, and from the third equation I have from the second equation I have -5k1 minus 8k2 plus 4k3 equals 0. So for k1 I have 8k2 minus 4k3 all divided by -5. So if I choose k2 equals 5, then k3 is -25. Plug into here, you have -25. Since k3 is -25 and k2 is 5, you will find out that k1 is -28 and my vector k is -28, 5, -25. Then my vector x1 is going to be k times e to the 2t. Now you are going to do the same thing for lambda equals -2 plus 3i. Plug it into here. That gives you a new matrix, which is this matrix augmented with 0. Okay, so from the third equation I got k3 equals 0. From the first equation I have -4 minus 3i times k1 plus 5k2 equals 0. So for k2 I got this one. If I choose k1 equals -5, then k2 is 4 minus 3i. The reason I chose -5 for k1 is because I want to get rid of fraction here. Okay, you can choose other values for k1, doesn't matter as long as it's not 0. Then my vector k is -5, 4 minus 3i, 0. Okay, so then your vector x2 is going to be the real part of vector k, which is -5, 4, 0 times cosine 3t e to the -2t y e to the -2t. You will go into take the real part of lambda for the exponent here, so that's why I have e to the -2t cosine 3t. So cosine times the imaginary part of lambda, which is 3, that's why I have 3t here. Okay, subtract the imaginary part of vector k, which is 0, -3, 0. Okay, multiply by e to the -2t, and then instead of multiplying by cosine 3t, I multiply by sine 3t. It's just the formula. Okay, you can stop at this step, but I can simplify this down by distribute this in and then add them together, which gives me this one. Okay, just like you add or subtract a matrix C together. Okay, that's for my vector x2. Now for vector x3, here's a cool fact about this. Once you know vector x2 for a complex value, once you know vector x2, you can find vector x3 by duplicate this. But here a few changes. You need to have one for positive and one for negative. Okay, and for this vector, switch the position of them. Okay, so over here you have this vector multiplied by cosine 3t. For vector x3, this vector multiplied by sine 3t, this vector multiplied by cosine 3t. Okay, you just switch the position of them and everything else stays the same. And then you can also simplify it down to this matrix. Okay, so your final solution is vector x equals c1 times vector x1, which is this, bring this down, plus c2 times vector x2, which is this, bring this down, plus c3, oh I'm missing c3, times vector x3, bring this down. Okay, so that's it.
If you find the video is helpful, feel free to give it a like, share, and subscribe to my channel in order to receive the most current videos. Don't forget to hit the bell so that you won't miss anything. I'll see you next time.